One single web request is all it takes to bring an entire system down. Web attacks today are no longer simple patterns. They evolve, they adapt, and they constantly change their form. Traditional defenses break the moment something new appears. Even AI systems fail because when they learn something new, they forget what they already knew. And worst of all, they never explain their decisions. But what if a security system could learn, adapt, and remember just like a human analyst? Introducing NeuraShield, an adaptive AI system for real-time web attack detection, designed to learn continuously without forgetting and explain every decision it makes. NeuraShield is not a traditional classifier. It uses a Siamese metric learning architecture to classify threats like SQL Injection, XSS, SSRF, and OS command injection with high accuracy and low latency. Live dashboards help administrators track attacks, confidence scores, latency, and traffic activities. NeuraShield shows why a request was blocked by highlighting suspicious payload parts and giving clear reasoning. Beyond known signatures, NeuraShield identifies unusual payload behavior that may indicate emerging threats. With continual learning, the system adapts to new attacks while preserving knowledge of previous threats. For large-scale deployment, NeuraShield includes a centralized super admin console. It supports customer management, model version tracking, system notifications, and review of escalated novel threats across the platform. NeuraShield can be hosted inside your own infrastructure, keeping API traffic, logs, and payload data private. Now, let's explore NeuraShield's architecture, understand how it works behind the scenes, and then see it in live action. Starting with the system context, NeuraShield is positioned as an inline security layer between the client and the protected backend application. All incoming requests first pass through the reverse proxy, where TLS termination and request buffering are handled before the request reaches the actual server. Instead of forwarding traffic directly, the proxy makes a low-latency API call to the inspection service. Inspection service is the decision-making layer of NeuraShield, responsible for analyzing, deciding whether it should be allowed or blocked. Now, let's zoom into that inspection service and see how the core architecture works. First, incoming traffic is captured and the payload is extracted into a model-friendly format. This extracted payload is then passed into our AI detection engine, which combines DistilBERT with a Siamese network. DistilBERT helps understand the semantic meaning of the payload, while the Siamese network compares the payload against learned attack patterns in the embedding space. For the final model, multi-similarity loss was selected, reaching around 97.8% accuracy while maintaining well-separated attack embeddings. After classification, the result is passed into the threat assessment layer. If the payload matches a known attack pattern with high confidence, the system can immediately classify it. But what happens if the request does not clearly match a known subtype? In that case, the novel threat detection module takes over. It evaluates novelty of the payload using a pure statistical method, which uses a Weibull distribution-based approach to model extreme deviations from known subclasses. Now, detection alone is not enough in a security system. Analysts also need to understand why a request was flagged. That is where the explainability module comes in. NeuraShield highlights the suspicious part of the payload and provides a human-readable explanation of how it influenced the model's decision. But the system does not stop after detection and explanation. When a new threat is confirmed, it is passed into the continual learning module. This module uses synthetic data generation, replay memory, and incremental training to update the model while preserving knowledge of previously learned attacks with the help of ICARL-based continual learning approach. Before any updated model is deployed, it goes through an accuracy threshold check. Only models that meet the required performance level are promoted into the model registry and used again by the inspection service. So overall, NeuraShield is not just a real-time attack detection system. It is an adaptive security framework that can detect attacks, explain its decisions, identify novel threats, and continuously improve as new attack patterns appear. This is the NeuraShield client dashboard provided to customers to configure and monitor how their APIs are protected. We ship NeuraShield as a complete self-hosted product designed to run entirely within the customer's own premises. Under the Overview tab, clients can see the total number of incoming requests, how many threats were blocked, the current block rate, and the average latency introduced by real-time inspection, all updated live. The Request Log tab allows customers to inspect every request, hitting their API endpoints in detail. Users can filter requests by threat status, protection status, request type, or search directly by IP address, path, or payload. This makes it easier to quickly find suspicious or blocked requests. For each request, NeuraShield displays the HTTP method, the model's confidence score, and the action taken, whether the request was allowed or blocked. Each log entry can be expanded to view the request origin, inference latency, predicted attack subcategory, and the top 5 closest matches from our 18-cluster embedding space, providing full transparency into every decision. NeuraShield provides full explainability for every detection. It identifies the exact payload fragments responsible for triggering the alert, validates them against learned attack patterns, and contrasts them with benign behavior. On top of that, the forensic analysis panel breaks down the threat determination, attack category, trigger anatomy, reason for detection, and potential impact, turning alerts into clear, actionable insight. The Analytics tab gives customers high-level security insights over time. It visualizes request volume versus detected threats, shows attack type distribution, and highlights the most targeted API endpoints, helping teams quickly identify patterns and high-risk areas. From the Protection Rules tab, customers can configure how their API endpoints are secured. Users can protect all endpoints by default or define fine-grained rules for specific APIs using custom patterns, allowing tighter security control exactly where it's needed. The Novel Attacks tab is where admins review suspicious requests that may not fit normal known attack patterns. Each flagged request is shown with important details such as the endpoint, source IP, nearest matching class, and review status. By opening a request, the admin can inspect the payload and decide whether it is malicious or a benign false positive. If the request appears to be a real emerging threat, the admin can either select a predefined category or mark it as a new emerging threat before escalating it to the super admin for further investigation. This gives NeuraShield a simple human-in-the-loop workflow to review unusual activity, categorize potential new threats, and support continuous improvement over time. The Health tab shows whether NeuraShield is running properly in real time. Customers can quickly check the overall system status and make sure the full security pipeline is healthy, reliable, and operational. This is the NeuraShield Super Admin Dashboard, used by our internal team to manage the overall platform. From the Customers section, super admins can view registered organizations, track their request volume, monitor blocked threats. Also, they can register new customer deployments through here. The Model section allows the team to manage AI model versions, upload updated detection models, and keep track of accuracy and version details. Through the Notifications section, super admins can send important updates to customers such as general announcements and model update alerts. Here is how a super admin can send a general notification to a selected customer. The platform also includes an attack pattern section, where newly identified attack patterns can be recorded. Most importantly, this dashboard connects with the customer-side Novel Attacks workflow. When an admin escalates a suspicious request, it appears here under Novel Threat Reports. The super admin can review the reported payload, customer details, assigned category, nearest matching class, and detection information before acknowledging the report for further action. Now, let's see NeuraShield in live action. First, we send a normal ping request. Since this request is safe, NeuraShield allows it to pass through, and we can see that it successfully reaches the backend. Next, we send a normal search request. Again, the request is inspected, classified as safe, and allowed to reach the backend application. Now, let's test an attack payload. Here, we send a SQL injection attempt through the login endpoint. Before this request reaches the protected backend, The inspection service analyzes the payload and identifies it as malicious. As a result, NeuraShield blocks the request and returns a 403 response. Finally, we test another attack using an XSS payload in the search endpoint. Once again, the request is inspected in real time, detected as a cross-site scripting attack, and blocked before reaching the backend. NeuraShield is built to protect modern applications and designed to adapt as threats evolve, delivering real-time on-premise security that learns continuously.